Hey everyone! Today we're diving into one of the most powerful machine learning techniques in the industry, gradient boosting, XGBoost, and LightGBM. These algorithms dominate Kaggle competitions and are used by companies for fraud detection, recommendations, and ranking systems. The core idea is simple but brilliant. Instead of training models independently like random forest does, boosting trains models sequentially where each new model learns from the mistakes of the previous ones. By the end of this video, you'll understand why these algorithms are so effective and how to use them. Let's visualize how boosting actually works. First, we start with our training data and build Model 1, which makes an initial prediction. Then we calculate the errors or residuals from that prediction. Here's the key part: Model 2 doesn't try to predict the original target, it tries to predict those errors. We calculate the remaining errors again, and Model 3 comes in to correct what's left. The final prediction is simply the sum of all models working together. Think of it like a team of specialists where each one focuses on fixing what the previous person missed. Let me walk you through a concrete example. Imagine we have a simple dataset where y equals 2x. Our first model naively predicts 3 for everything, giving us errors of -1, +1, and +3. Now here's the magic: the second tree doesn't predict y, it predicts these residual errors. The prediction improves. A third tree comes in and corrects what's left. The formula shows each tree is added to the previous prediction, multiplied by a learning rate. A small learning rate like 0.1 means we only take 10% of each tree's contribution, which makes training slower but more accurate and helps prevent overfitting. Now let's talk about XGBoost, which stands for Extreme Gradient Boosting. XGBoost took the machine learning world by storm because it's basically gradient boosting on steroids. It adds regularization to prevent overfitting, prunes trees to remove useless branches, and uses parallel processing to train way faster. The code is super clean too. You just import XGB classifier, set your hyperparameters like number of trees, learning rate, and max depth, then fit and predict just like any Sklearn model. The key hyperparameters to tune are n_estimators for how many trees you want, learning_rate for step size, and max_depth to control tree complexity. LightGBM is Microsoft's answer to gradient boosting, and it's incredibly fast. The secret sauce is how it grows trees. Traditional boosting grows trees level by level, creating balanced trees. LightGBM uses leafwise growth, meaning it picks the single best leaf to split next, even if that makes the tree unbalanced. This reduces loss much faster. It's optimized for large datasets with millions of samples and uses way less memory. The API is almost identical to XGBoost, so switching between them is easy. In practice, LightGBM is usually faster while XGBoost might be slightly more accurate, but they're both excellent choices. Alright, let's wrap this up. Boosting works by training models sequentially where each one fixes the mistakes of the previous model. Gradient boosting specifically trains trees to predict residual errors. XGBoost optimizes this with regularization and parallel processing, while LightGBM goes even faster with leafwise tree growth. In terms of performance, they typically beat random forest and are roughly equal to each other. My recommendation: start with XGBoost for most problems, switch to LightGBM if you're dealing with massive datasets. Focus on tuning n_estimators, learning_rate, and max_depth. Now you understand why these algorithms dominate Kaggle and power production systems at major tech companies. Go experiment with them. That's a wrap on this one. If this video helped you understand the concept, please hit that like button, it really helps the channel grow. Subscribe so you never miss a new video, and drop your questions in the comments below. Share this with a friend who's learning, and I'll see you in the next one.